Hello, Algebra 2 Trig Honors classes. This is Mr. Skaer. I apologize, I have not been in school the last 3 days last week, and it looks like I won't be there today, obviously. So I'm going to take you guys through section 2.5 in a nutshell here, and hopefully this will kind of help put a lid upon this section. I hope section 2.4 went okay for you. Whatever day I return, I'll make sure to go over questions on that. And I know you've had a couple of assignments over this section already. Today will be the third assignment for that. I'm going to kind of take you through a little bit of everything that we've talked about so far. And hopefully, if you need to, you can also kind of go back to some of those previous questions and maybe get those answered. So to begin with, we should probably first talk about the concept of the fundamental theorem of algebra. If you read that in the section, you saw that if you have a function that is a polynomial with a degree that is greater than 0, meaning first degree or higher, then that function needs to have at least one 0 in the complex number system. Not just the regular real number system, but the complex number system. So in other words, what we're saying is, if it's first degree, you should have 1 0. If it's second degree, 2 0, third degree, 3 zeros, etc. Even though some of those zeros might be complex numbers, which are just beyond the realm of the real numbers. Okay? You also have the linear factorization theorem that talks about a function that's a polynomial where it has a degree of 1 or greater. That means there are going to be exactly n factors. Now that's linear factors. So if it's first degree, there's 1 linear factor. If it's second degree, there's 2 linear factors. If it's third degree, there's 3 linear factors, etc. And some of these factors might be rational numbers associated with them. They might have real numbers. They might have complex numbers as well, okay? But the point being is that basically the number of zeros, the number of factors, is determined by the degree of that polynomial function. And that's why we spent time looking at what a polynomial function was. The next thing I want to talk about, so then we can look at some problems, is that rational zero test, which, again, if you kind of look at it, they talk about your P's and your Q's. So I want to take you back to a real simple function like this, okay? So f of x equals 2x squared minus 3x minus 9. Now, if we're going to go after the factors of this, or the zeros, either one, we would normally set this equal to 0. Now, if you think about it from your days in Algebra 1, you always concentrated on this number and this number first and foremost before you actually looked at this. So you were thinking of all your factors for the number -9, which they're going to call this your p-value. Then you also looked at your factors of 2, which they're calling your q-value. So if you look at it, your p factors are going to be plus or minus 1, plus or minus 3, plus or minus 9. For your q values, you're going to look at plus or minus 1, plus or minus 2. So you always created 2 factors like this, but weren't your numbers that were going to go here related to factors of this somehow? And in fact, wouldn't these as a ratio create your potential zeros? Not necessarily all of them, but potential zeros. So in terms of my potential zeros, they're either 1 divided by 1, plus or minus 1, 3 divided by 1, so plus or minus 3, 9 divided by 1, plus or minus 9. Or 1 divided by 2, plus or minus a half, 3 divided by 2, plus or minus 3 halves, or 9 divided by 2, plus or minus 9 halves. Now in the end, there are 2, 4, 6, 8, 10, 12 possible zeros. Can they all 12 work? No, it's only second degree. At most, only 2 of these can work. Okay? If we actually go through and look at it, it should be able to factor to 2x and a x, and I believe it's going to be 3 and 3, where we want to have the 6 here be a negative and this be a positive. So those are your 2 factors. If you set them equal to 0, x equals negative 3/2, x equals 3. We found the 3 right there as a 0. We also find the negative 3/2 right there as a 0. Again, these are potential numbers. They won't necessarily work. Don't always assume that, because this will not give you your complex zeros if there are any, or anything higher than the rational level like an irrational number or a rational. Excuse me, it will give you the rational. Okay? So that's the idea behind that type of problem. Now, read directions carefully, because I may want you to come up with the complete list of zeros, which we did right there. So zeros are negative 3/2 and 3. Or I might want you to come up with the complete factorization, which is 2x plus 3 times x minus 3. Okay? So we're going to take that idea and just continue to expand upon it past a second degree. All right? Now, the idea of what you want to do here is, the first and foremost, when you go to find zeros or complete factorization, the ideas that you want to take into account: number 1, see if you can factor. Always take the look right off the bat and see if you can factor, even if it's as simple as a GCF. Okay? Second thing, try the rational zero test. Not necessarily writing them all out for sure, but at least have that in the back of your head when the list gets pretty big. Okay? I know you will be able to use some technology here from time to time. So you can kind of use technology in conjunction with the rational zeros to whittle down your list. Okay? If you do use technology and you find that you found a 0 based off your calculator, I need you to justify that it's a 0. Probably the best way, use synthetic division. Okay? If you find a couple of zeros, do synthetic division twice to whittle it down. And we talked about this in class. Your best friend is always going to be trying to get down to a second degree. Okay? The next thing to know is that they could occur, zeros can occur in complex, conjugate, sorry about that, just start over there, pairs. Okay? So if by chance you get 7 plus I as a 0, you know 7 minus I is a 0. If you get just I, then opposite I is a 0. If you get negative 4 plus 3i, negative 4 minus 3i is also a 0. Okay? So keep keenly aware of that. All right? As far as we talked about, get to a second degree, because if you're down to a second degree, then you might be able to factor it. If not, you could complete the square or use the quadratic formula. But just make sure in the end that if you find the complete factorization, if you were to multiply it out, you would get back to the original polynomial function. And if you have the complete list of zeros, that it matches the degree. Okay? Make sure everything's justified. Do not leave anything to chance for me to try to understand what you did. Okay? So, let's go ahead and take a problem and see if we can work through it. I am going to use technology as well, so if you have your calculator, you might want to grab that, and we'll start working on a problem like this. Okay? So, f of x equals x cubed plus 4x. On all these problems, I'm going to ask you to do the complete list of zeros and the complete factorization, so I want them all. So right now we know that we need to get 3 zeros and 3 linear factors. All right. I'm hoping the first thing that you noticed right off the bat is you can factor it. GCF can come out. All right. So now f of x equals x times x squared plus 4. All right. Now this almost looks like a difference of squares. It's a sum of squares because of the plus sign. In the past, we weren't able to factor sum of squares, only difference of squares, by using conjugates. Sum of squares can now be factored because we've introduced the concept of the imaginary unit. So you will make conjugates, but it will be with the I. So x plus 2i and x minus 2i. The reason that that is going to work is, one, they're conjugates, so you only have to do the front, which is x squared, and the last, which is, if you multiply it, is negative 4i squared. But do you remember what I squared is? Negative 1. So negative 4 times negative 1 is positive 4. So this right here is your factorization. If I was to multiply all of that back out, I should get there. My complete list of zeros would be 0, negative 2i, positive 2i. So 3 factors, 3 zeros for a third degree. That one I didn't even need to use technology on. If you do decide to graph that, you will notice that you will not see these zeros because they are imaginary values. That doesn't mean they're made up, but they are still values that will make this become 0. The only one that you'll see is that graph should cross the x-axis at 0, the origin. Okay? All right, next one we'll move on to. F of x equals 7x to the 4th minus 29x cubed minus 17x squared plus 129x minus 18. So first off, when we go to look at this, we've got a 4th degree, so our first thought should be we need to come up with 4 zeros. Also, we need to come up with 4 factors. Okay? Now the problem is you start looking at this and you think, okay, can I factor it? Well, a lot of these numbers do not play well with other numbers. In fact, I set it up this way to see not everything is factorable, but we should still be able to do this. Okay? So what I'd first think about is, okay, what are your P's and Q's? Okay? So mind your P's and your Q's. You've always heard that expression, whatever it might mean, I don't know. But we're trying to think of all the numbers or factors of 18 divided by the factors of 7. Okay? That would be quite a list, but I want you to keep that in the back of your head. What we're going to do is go ahead and take a look at the calculator. So we'll go ahead and type this in. 7x to the 4th minus 28x cubed minus 17x squared plus 129x minus 18. Just going to do a quick take that I've actually entered that in correctly. I'm going to hit the graph, and what I notice is that it really streams across the picture really fast. It doesn't look like it goes past -2. It doesn't look like it goes past 3, but it shoots up and down really fast in a hurry. So I'm going to get a better scope on this window, and I'm going to go ahead and I'm going to limit it from, say, -4 to 4 on the x, so I'm going to compress it in. I'm also going to, because it took off in a hurry up and down, I'm going to really widen out the range values quite a bit to maybe get a better grasp at it. Now it's hard for me to tell what these are because, I mean, I only went by ones here, so it's hard to tell, but it does look or appear that it crosses at maybe -2. Does it cross at the origin? Well, look back at this. Is x a factor? No, so it's close to 0, but it's not 0. And then it looks like it crosses at 3. Actually, it looks like it bounces at the number 3.